G'day YouTube. Today what we're going to do is we're going to do some investigation the burning of the HDPE milk bottle plastic. Okay, I've had issues in the past where the plastic is gone a yellowy colour. Okay, what I've done in the past is I've made this this billet. Okay, now, and what we see here is we have this yellowing effect here. Okay, and we have this one here. Looks like a bit of burnt bacon or brown bacon. Now there's white. Okay, now the question is this burnt? Is that burnt because the temperature I had it was too high, or is that a milk residue? Okay, I think the thing being is the temperature may have been too high. Okay, so possibly one of the properties of, say, the milk bottle plastic is that when the temperature gets high, that's when it'll burn. All right, so to try and rule out the fact if it's milk. Okay, so what I've done is I've cut up some milk bottles. There's a few in here. And what I've done is I've boiled these, dried it, and boiled them again. Okay, so that way, hopefully, there'll be no milk residue on here at all. And we'll see how this goes. What we do is we just put a few on our little thing. Spray some mold release on it. Well, yeah, that's another question we've got to find out is a mold release. Yeah, sometimes it just sticks. Like that. That's for another day. I'll just put those in the oven. And what we'll do is we'll try and... I've got the oven set at 170 and we'll see how that goes. I've pretty much just taken the sample out of the oven. Okay. This is at 170 degrees. Okay, it has melted, and it's quite plastic. Oh, that's funny. It's quite moldable. Okay, as you can see, it's starting to whiten. So it's starting to cool down pretty fast, but you can work it. You can press it. Oop. Okay, so at 170 degrees, it's pretty good. So we haven't got to the stage of burning yet, which is good. As you can see, it whitens up before your eyes. What we could do later on is another experiment is we can actually put this through a passer machine. It gets to a certain stage, put it through the passer machine, roll it into a flat sheet. That'd be interesting. We'd have to work fast though because it cools down pretty quickly. Anyway, so at 170 degrees We have no signs of maybe I'll coin the term baconing as like bacon, baconing. Bacon, baconing. I think that's a good term. Right, so now what we do is we put it back in the oven and we increase the temperature. Probably this time we'll go to 180 and we'll see. G'day, this is day 2 of the experiment. Okay, this one here, it was done, we melted this with at 180 degrees. Okay, now we've just changed the oven and we're going to melt this lot here at 190 degrees. And we'll see if this one starts to baconize. Okay, what I've discovered is that our first one here, that was done at 170 degrees, and that looks all fine. Okay, this one here is done at 180 degrees, and this one's all fine too. Okay. Now this is where we see our baconizing effect. Okay, we started to burn here. So this is the plastic burning. Okay. Now originally I thought that possibly could have been a milk residue. Okay. Then the way I ruled that out is that I'd washed the I've washed all my milk bottle material about 2 times. I've put it in the and boiled it twice, so this should be free of any milk residue. So it's not the milk residue. So it is actually the burning of the plastic. It hasn't affected the plastic anywhere. It's just basically the colour started to tinge. Right. So if you don't want that, you need to keep within a range of 170 to 180. Possibly you could go a little bit higher than 180, but if we go higher, then we get the baconizing effect. That's something that you'll have to experiment with. But at the moment, we stick between 170 and 180, and we should be fine. These are the HDPE milk bottles in Australia. I imagine it'd be the same in all other countries. Alright, see ya.